Hey there, Python enthusiasts. Welcome back to our channel. Today, we're diving into a topic that might seem a bit mysterious at first but is super powerful once you understand it: Python decorators. So, buckle up, because by the end of this video, you'll be decorating your Python code like a pro. So if you are ready, let's get started. Alright, let's start with the basics. What exactly are decorators in Python? Well, in Python, decorators are a powerful and flexible tool used to modify or extend the behavior of functions or methods. They allow you to wrap another function or method in order to execute code before and/or after the wrapped function runs. Decorators are essentially functions that take another function as an argument and return a new function, usually adding some kind of functionality in the process. Here's a detailed explanation of how decorators work and how to use them. 1. Functions as first-class objects. In Python, functions are first-class objects, which means they can be passed around and used as arguments, just like any other object. 2. Nested functions. Python allows defining functions inside other functions. These are known as nested or inner functions. With these two concepts in mind, let's see how decorators work. Here is the basic syntax of decorators. Here. Decorator underscore function, this is the decorator itself. It takes the original function, original underscore function, as an argument and returns a new function, wrapper underscore function, which wraps around the original function. Wrapper underscore function, this function is the actual wrapper that adds functionality before and/or after calling the original function. It takes any number of positional and keyword arguments, asterisk args and quargs, to ensure it can handle functions with different signatures. At decorator underscore function, this is called a decorator syntax. It's a convenient way of applying the decorator to the function immediately after its definition. Here is the basic example of a decorator in Python. In this example, log underscore decorator is our decorator function. It takes the original function func as an argument and returns a wrapper function wrapper. Wrapper is the wrapper function that adds logging functionality around the original function. It prints out information about the function call, including its name and arguments, before and after calling the original function. At log underscore decorator is the syntax applies the log underscore decorator to the add function. It's equivalent to writing add equals log underscore decorator, add. Add is the original function we want to decorate. It takes two arguments x and y and returns their sum. We call the add function with arguments 3 and 5. Since add is decorated with log underscore decorator, it actually calls wrapper 3, 5, which in turn prints out information about the function call and then calls the original add function. Finally, we print the result of the add function call. This demonstrates how the decorator log underscore decorator wraps around the add function, adding logging functionality without modifying the original function itself. Decorators like this can be extremely useful for adding cross-cutting concerns like logging, authentication, or caching to functions in a clean and reusable way. Advanced usages. 1. Passing arguments to decorators. You can modify the decorator to accept arguments if needed. 2. Class-based decorators. Decorators can also be implemented using classes instead of functions. This allows for more complex behavior and state management. 3. Multiple decorators. You can apply multiple decorators to a single function, each providing its own functionality. The decorators are applied from the innermost to the outermost. Here are some common use cases of decorators. 1. Logging. Decorators can be used to log information about function calls, including the function name, arguments, and return values. This is particularly useful for debugging and monitoring the behavior of your code. 2. Authorization/authentication. Decorators can enforce authentication and authorization checks before executing a function. This ensures that only authorized users have access to certain functions or resources. 3. Caching. Decorators can implement caching mechanisms to store the results of expensive function calls and reuse them when the same inputs are provided again. This can significantly improve performance, especially for functions with repetitive computations. 4. Timing. Decorators can measure the execution time of functions and log or display this information. Timing decorators are helpful for profiling and optimizing code, identifying performance bottlenecks, and monitoring the efficiency of algorithms. 5. Error handling. Decorators can wrap functions with error handling logic to catch and handle exceptions gracefully. Error handling decorators can log errors, retry failed operations, or provide fallback behavior to prevent crashes and improve the robustness of your code. These are just a few examples of how decorators can be used to enhance the functionality, performance, and reliability of Python applications. So there you have it, folks. Python decorators are a powerful tool for enhancing your code in terms of reusability, separation of concerns, and readability. By mastering decorators, you can write cleaner, more maintainable code that's easier to understand and extend. Decorators are an elegant and powerful feature of Python, widely used in frameworks like Flask, Django, and many others. They enable cleaner, more modular, and more reusable code. That's all for this video. If you found this video helpful, don't forget to subscribe, give it a thumbs up, and hit that notification bell for more content, so you don't miss any upcoming video. And, if you have any questions or topics you'd like us to cover in future videos, please let us know in the comments below. Until next time, keep exploring and keep coding. Thanks for watching, and happy coding.